uncapped internet from as little as $500 million a month. Contact us now or find us on Facebook. White Owl, your internet service provider.
Right, so the first one there is the triangle that you have there. Okay, triangle ABC. In the triangle above, construct the locus of points equidistant from A and B. What will this be? Between two points, what will it be? A line, a perpendicular bisector, a perpendicular bisector. So make the construction of the perpendicular bisector. You can take any length, yes, it must just be more than half, more than half. The next one says the locus of points, which are, this construction is the worst one. This is where the mistake comes in. Look at this one. Equidistant from AB and AC. So what does that mean? Of AB and AC means it's the angle bisector. When it repeats like that, AB and AC, it is the angle bisector. So you can choose any arc. The secret is just to use the same arc there. So from A, we draw an arc. Then you put it here, and you put it there, and there is your angle bisector. So the third construction is the locus of points 9 centimeters from C. What is it from a point? A circle. So 9 centimeters now from C, so we measure and we construct then 9 centimeters from C, you construct a circle. Don't need to draw the full circle, just that part which is inside the triangle. Your line is too short. Draw it longer. You're not going to get the mark for that one. Your lines must go through the whole triangle. Don't draw it too short. The last one is a circle from from C. A 9 centimeter circle from C. Okay. Now, what we're going to focus now more on is those shadings. We've looked at the constructions. Now we're looking at the shadings. If you don't know, put up your hand, then I will come and help you. Okay. Now it says shade. Look now on your shape. Shade the region inside the triangle which are closer to A than to B. So what does that mean? It's up here. Then they say closer to AC than to AB, which means it's on that side, isn't it? And then the last one is more than 9 centimeters, so it must be more than 9 centimeters. So it's closer to A to B, then closer to AC than to AB between this line and more than. So this is where you're going to shade. That's then the part that you have to shade. Yeah, mine is small. Yours will be a little bit bigger. Okay, number 2, shade your region. Right, we're going to go over to number 2. It's another triangle. So there is the triangle ABC. ABC. Usually it goes like this. The treasure, so there's a treasure hidden in a triangular field ABC shown in the scale. There's again a scale, 1 centimeter represents 10 meters. The treasure is nearer to AB than to AC, more than 10 meters from the line BC, but less than 50 meters from the point C. Okay, now let's first make the constructions and then we'll find the treasure. Equidistant from AB and AC. What is that? Angle bisector. AB and AC is an angle bisector. So you choose any arc and you draw the arc there. Then you use exactly that same length to make those arcs there. You put it there, and we draw the angle bisector. The angle bisector. The second one is 10 meters from BC. So what will that be? Yeah, a line 1 centimeter from BC. So there is the line, 1 centimeter from BC. 1 centimeter from BC. Make the construction, 1 centimeter from BC. You just use the same one. Okay, the next one says 50 meters from C. What is that? From a point, it is a circle. So from C, it's going to be a circle. So draw your circle. 5 centimeters from C. We draw a circle. Okay, where's the treasure? I'll read and you look on your papers. The treasure is nearer to AB than to AC. It is more than 10 meters from BC. And it is less than 50 from C. Where's the treasure? There's the treasure. There's the treasure. Now, closer to AB than to AC, more than that line, less than 5. It's just that part there. It's that part there. Okay, let's turn around. Number 3. PT and PU are tangents to an arc of a circle at T and U. Using straight edge and compasses only, construct the bisector of angle TPU. Okay, you do it now, and by drawing another line, find the center. You had that circle, it was not a full circle, 2 tangents from the same point, and the first construction that we made was the angle bisector. So that's now the one line that you have there. Now, to find the center of the circle, the other thing that we need to know is that the tangent to the radius is 90 degrees. So you have to construct here an angle with 90 degrees. Or here, doesn't matter. Construct an angle of 90 degrees, and then where the 2 lines intersect, that's why you find the center O. So draw the tangent is drawn, form an angle of 90 degrees, and if you join that, you will find, so that's because they ask you to draw an extra line. So that's how we find that extra line then there. So construct an angle of 90 degrees, and then you will get that. Okay, and we're going to do the last one, number 4. So here is the sketch. Right, write the scale in the form 1 to n. Now, the actual length of the side AB is 100 meters, so it's 1 to 10. So the ratio is then 1 to 10. 1 to 10, n is 10. N is 10. The next one, in this part, use a straight edge and compasses only. So basically, you're going to use the compasses. That's what we're going to use. Leave your construction lines. We said that now. A tree in the field is equidistant from A and D. What does that mean? What is the construction if it's equidistant from A and D? Yes, a perpendicular bisector. So you choose an arc more than half. You put it on D. You make that arc. You put it on A. You make that arc. And then you draw the perpendicular bisector. So there is the perpendicular bisector, the construction there. The perpendicular bisector. And then they say the tree is also equidistant from BC and CD. What is that? If I say BC and CD, this is the angle bisector. Look at this. This is always where it goes wrong. So again, some of you are still struggling. I take an arc. Pesci, look here. I take an arc. I make the construction there. Then you put it on that line DC. You put it on BC. And this is then the angle bisector. The angle bisector that you construct. Okay, the angle bisector. And where are you going to plant your tree? T. That is the point where we plant the tree, at T. Where your line, your 2 lines intersect. Yeah, the line is a little bit more skewed, isn't it? So let's look at that first one there. This is then the class test on Loci. VWXYZ is a straight line. A triangle has sides of 3, 4, and 5 centimeters. It starts in position A and is rotated about its vertices as shown on the diagram. Construct the diagram accurately. So you must do that first now. Construct the diagram accurately. So it's real dimensions. You have to draw it with real dimensions. Sketch that you made. This one was eventually 12 centimeters. There, and that one, and there. Okay, construct the diagram accurately. Some of you struggled a little bit, but we must make those constructions. Then they say, construct accurately the locus of the vertex P as it moves from P to P dash. Now, that was then with your compasses that you could do that one. Here is P now. This is the point P, and I have to go over now here to P dash. So, what will be the locus of P? Now, if you take your compasses and you put it here, and it moves from that P, then it will go there, and then it goes up. So your locus will look something like this. That would be the locus of that point. Where's yours? Then they say, describe fully the rotation which maps B onto C. Now, if you struggle with these things, take your rubber and do the movement with your rubber. Mark on that one, so then you can see how it will change. So what is the movement from B to C? It is a rotation, isn't it? Okay, now this is transformations. We haven't done it now this year, but you already did it in grade 9. So it's a rotation. What is the center? What is the center? Okay, center X. And then we also have to say with how many degrees. This is the angle. This is the movement there. It moves from there to there. So you have to measure that angle there. It's not 180. I think it's 165 or something like that. Yeah, okay. So, and then with 143 degrees. So this is the movement. That is the angle that you have to measure there, because it rotates like that. You can see how they combine these questions as well here. And then the last one says, describe fully the single transformation which maps A onto D. So the answer there is a translation. We call it a translation. A translation is like chess. It is a movement, and we do a translation with a vector, and the vector is now this movement here. So we have to add all the lengths of these sides. Now, this one was 3. This one will be 5. This one is 4. And this one is 3. So what is it in total? 15. So then is the translation with a column vector 15, 0. But that is something that we still have to... 0 because there is no movement up or down. We'll come back to this later on. Okay, question 2. I asked, this one is very similar to that donkey one that we had the other day. Okay, the diagram shows the scale 1 centimeter to 1 meter. It's the garden. It's tethered to a rope at P. So here's your P. There's P. And they say draw the locus of all the points in the garden that the goat can reach when the rope is tight. So that will be a 4 centimeter circle that you're going to draw there. A 4 centimeter circle there. And then the last one, calculate the area of the grass that the goat can eat. Now, what will be the area that the goat can eat? It will be this part. No, this is where he can eat. Sorry. This is where he can eat. So it's a quarter of a circle, radius 4 centimeters. So it's then a quarter of pi 4 squared. What did you get? 12.6 square centimeters. No square meters. Yeah. Otherwise, the goat can't eat much. Right. Now we come to the last question at the back. This was now a good exercise for you at home on your own. So number 3 now there. Okay. In this question, show clearly all your construction arcs. So we said you don't rub it out. Using straight edge and compasses only. The perpendicular bisector of BD. Now, this is B and this is D. So the perpendicular bisector means now it's of this line here between them. So you will put your compasses on B and draw an arc. And you will put your compasses on D with that same length. And this is then where we draw the perpendicular bisector of BD. Remember, it's now that line. Oh, mine doesn't look very nice. It's a perpendicular bisector. Then they say the bisector of angle CDA. So this is the angle that we have to bisect. So if we bisect this angle now here, you make that arc. So I take again any arc length. And the secret is to keep that arc length. And then you put it here, make an arc, there, make an arc. And this is then the angle bisector, Shape the region inside the quadrilateral, which is nearer to D than to A. So this is now this line closer to D, and then nearer to DC than to AD. So where are we going to shade? Here, isn't it? Here. This is where we're going to shade, yeah. Yeah, you shouldn't cross this line here. Okay, so that is then the homework. That was the homework. So now we're going to make nets today. We're going to draw now nets of shapes. Nets. Now, usually you can just summarize it in your book now first. So if we have a cube, then the basic net looks like this, where you have the 6 faces and those 2 wings. If it is a cuboid, then these 2 will be equal and those 2 will be equal. The big thing, you must summarize this. The big thing that we need to remember now is that these sides fold on top of each other. So they must be equal in length. All the sides that's going to fold are equal in length. You can have others also, but for the cube and the cuboid, this is basically, or this is the easiest one to do. So there's the cuboid. So we have a smaller one and a bigger one, smaller one, and again, those wings, those lines should be equal to fold on top of each other. That's what's very important there.
Win free airtime with One Africa TV. Share your comments on the channel. WhatsApp your feedback, name and town to 081 200 6659. One Africa TV. It just gets better.
So this is then the revision exercise, exercise 7.1, and we're doing then answering the questions starting at number 6. So there you've got the picture there, the line y is equal to 4. So this is what we have here. There is the line y is equal to 4. There's no gradient, and it meets the line 2x plus y is equal to 8 at the point A. Find the coordinates of A. So what will it be? Coordinates is solving simultaneously. This one is actually very easy because you can just say 2x plus 4. So I substitute the 4 in y's place is equal to 8. So the value of x is then 2. X is equal to 2. So what is the coordinates? Because they want coordinates, so you must give it as a coordinate. Read the question. So it will then be 2, 4. 2, 4, which is the coordinate there. Then the next one, the line 3x plus y is equal to 18 meets the x-axis at the point B. what is the coordinates of B? Now, it is 3x plus y is equal to 18. We know now that when you meet the x-axis, y is 0, isn't it? So then we can just say 3x is equal to 18, which makes x equal to 6. Now 6. So the coordinate is 6, 0, because you cut the x-axis. And then the next one, find the coordinates of the midpoints of M joining the line A and B. Now, we have the coordinates of A and the coordinates of B. So this is the two that you are working with now here, this one and this one. And now we have to find the midpoint. So it's just the midpoint formula, 6 plus 2 over 2. You can't say that this is difficult, 0 plus 4 over 2. It's just my formula, and the answer is then 4, 2. So the midpoint is 4, 2. And then they say find the equation with a line parallel to that line. So if it is parallel, now just remember this one, 3x plus y is equal to 18, is now not in standard form. So it means you do not have a gradient at this stage here. Right, so what is the gradient of this one? So m is negative 3. So the equation will be y is equal to negative 3x plus c. And this line passes through the through M, through the midpoint. What was the coordinates of M again? So 2 is equal to negative 3 times 4 plus C. This is how you will calculate C, the value of C, 14. So the equation is y is equal to negative 3x plus 14. Don't forget to write. Right, the next one is question 7. A is the point 5, 10, B is the point 30, negative 2, and it is 2 points. The perpendicular bisector of the line has a gradient of 2/3. They give you the gradient. Find the equation of the perpendicular bisector. So I still want y is equal to mx plus c. They are so nice, they give you the gradient and they say it's 2/3 x. How do I find c? Which point should I substitute? The midpoint, because it's the perpendicular bisector, and at this stage I don't have the midpoint. So I first need to calculate that. This is the midpoint. You have to calculate the midpoint. 9,4. Okay, so now I can substitute it in here. So 4 is equal to 2/3 times y plus c. Negative 2. So the equation is y is equal to 2/3 x minus 2. Minus 2. Understand? Okay, so that's then the equation. That was what our further homework was, isn't it? So now we're going to start with, right, so the picture looks like this, and we have this one. Okay. So A is negative 3, 3, B is 3, 9, C, write your coordinates in so that you can see it, because the coordinates is now not where they should be. And this one is then D, negative 3, 3. No, 0, 3, negative 3. So write them in. That's what the word respectively also means, is each one is that point. So the first question now there is calculate AD. Now remember, this must be one of the 3 formulas. It must be one. You must just find out which one it's going to be. So if I say find the length of AD, then it means that I'm going to find this line. This is then the line AD. That's what you need to find. How do we do that? With a length formula. Okay, do that one on your paper. Do it with the length formula. We all do this question now together. You shouldn't wonder, must I add or subtract? What is your answer for the midpoint? Okay, so what do you say? Okay. Okay, and then they say, show that the line AB is parallel to DC. So let's go back to the sketch. AB must now be equal to, AB must be parallel to DC. When will they be parallel? If their gradients are the equal. So calculate the gradients now. So now we're talking about the gradient formulas. It's one of your three formulas. So this time it's the gradient formula. AB and DC, you have to calculate both of them, AB as well as DC, finding those gradients, finding the gradients. So this one's gradient is equal to this one, so I make the statement again, AB is parallel to DC. Make that statement, AB is parallel to DC. Hence give the geometrical name of the quadrilateral. Just look at the shape. Yes, you're right. It's a trapezium. It's a trapezium. I've got the two parallel lines now. That's what you've proven. So it's a trapezium. And then the last one, obtain the equation of DC. That is the diagonal that we need to calculate now. DC. So what do I want? If I must obtain the equation, what do I want? What is the equation of the line? So we said, what we want is M and we want C. We already have the, now, yeah, we already have the gradient. So Y is equal to 1x plus C. Which one? D or C? D or C, because it passes through those 2 points. So you substitute one of them in there. D or C. What is D? Negative 3 is equal to 1 times 3 plus C. So what is C? Negative 6. So your equation is Y is equal to 1x minus 6. Minus 6. Okay, this is what you're going to get. This is exactly what you're going to get, this question. Like this one. Okay, so would you get 12 marks here? Okay, so now I want you to continue with that revision exercise. Let's continue then with the revision exercise, number 1, 2, and 3. Grade 11s, we are busy with a final revision exercise then, ready for, and I think we should start with number 2, marking there number 2. Right. So the first one says, using a scale of 1 centimeter to represent one unit on each axis, draw the following lines. So I said you can do this one just in your books. We'll do the second one on graph, or there is actually graph paper there. Okay, so the equations that we are drawing is y is equal to 2, x plus y is equal to 6, and y is equal to 2x. And by now, this should be very easy for you to draw these lines now there. So the first one, y is equal to 2. So this is then here, and that is the line that we are drawing there. So it's just the lines. This one changed to standard form, so y is equal to negative x plus 6. So we start here at 6. We've practiced this method now a lot of times. The gradient is 1 over 1, or you also know that you'll have to cut here at 6 also, if it is a 1. And there's then my straight line for that one. Be careful, sharp pencils to draw that one. What about this one? There is no C, which means that line starts here at 0. What is the gradient? Delta y over delta x, 2 over 1. 2 over 1. Okay, you're right, it's delta y over delta x, so it's 2 over 1, like this. There's the 2 and there's the 1, so this is the line. Sorry, yeah. Okay, and then let's just get the inequalities. So y is more than equal than 2, and the last one less than equal than 2x. So first we've drawn the lines. Now we need to shade unwanted regions. This is the wanted region, so I'm shading here. If we test this one, is 0 more than equal than 6? No, that's false, isn't it? So that means for this line, 0, 0 is in the unwanted region. So I'm going to shade here. And then the last one, Now it doesn't help to take the point 0, 0, so we need to take another point here. Like, 6 is less than equal than 12.